I am going to discuss about RIP, Routing Information Protocol, which is example of intra-autonomous system routing protocol. Yes. So as I said, it is intra-autonomous system routing protocol which helps us to route the or find the shortest path inside the autonomous system from one node to other node inside the autonomous system. So we have like three protocols in intra-autonomous system routing. One is RIP, other is OSPF and IGRP. First we'll see RIP. Yes. So it is included in BSD Unix distribution at the year 1982. And how we are going to find with which routing protocol it is going to find the shortest path between the nodes in the same autonomous system is with the help of distance vector routing algorithm. Yes. So distance metric is like every here there is a fixed link cost, that is for every link the cost is 1, and maximum number of intermediate hops between the source to the destination can be 50. This is the distance metric, and distant vectors exchanged with the neighbors every 30 seconds. Yes. If I can connect to a particular node, then I can give the advertisement to my neighbor that you can connect this node, you can connect the node called you through me. The same advertisement will be forwarded to its own neighbor, and that neighbor will be forwarding it to its own neighbor that you can be reached through A, and B will send to D that you can be reached through B and A. D will send to C that you can be reached through D, B and A. And again C will send to A that you can be reached through C, D, B, E, A. So this is how the information distance vectors are exchanged in the form of advertisement every 30 seconds. So by this we'll be coming to know all the nodes in that particular autonomous system, all the routers in the particular autonomous system will come to know that whether all the routers are alive or not. If it is not going to get the message for a duration of 180 seconds, then it will assume that the particular router is dead, and it will take out the entry of that particular node or subnetwork from that network. So each advertisement lists of up to 25 destination subnetworks. So every advertisement can have 25 destination subnetworks information. Yes. So this is the example given, that is from router A to the destination subnetwork. Who are the subnetworks here? U is a subnetwork, V is a subnetwork. See, U is a subnetwork, V is a subnetwork connected to the router B, and W, X is a subnetwork, X and Y are the subnetwork connected to D, and this is Z is the subnetwork connected to C. So this subnetwork will be having hosts. Will be having host connected to the subnetwork. Okay. So what happens from the router A to the how to reach these subnetworks called U, V, W, X, Y and Z from A. So this is the routing table from router A to how to reach all the subnetworks. See, from from A to U, what is the cost? It is nothing but number of hops. We said the link cost is 1 always, as we said here. So 1. And how to reach from A to V, what is the cost or number of hops? It is 2. So 1 plus 1 is 2. And W, from A to W, if you check 1, 2. So W is 2. And X, so 1, 2 and 3. So 3. And how to reach from A to Y? 1, 2, 3. So 3. And how to reach from A to Z? A to C and C to Z, that is 2. Here 1, here 1. That is 2. So this is how we have to find the routing table using the link cost. Yes. See here, this is the destination subnets. Here one more parameter is added, like next router. If I want to reach from D to W from the router D, from the router D, from the router D to W, what is the next router? So through A only, the next router is A. So I am mentioning here A, and how many links are there in between intermediate hops? That is 2, 1 plus 1, 2. So I have given 2. So how to reach from D to Y? This, what is the next router? It is B. So I am mentioning B here, and the link cost 1 plus 1 is 2. So 2 is here. And how to reach from D to Z? So D to Z, if you check, the next hop router is B, and intermediate so many number of links are there. So finally they calculated as 7. So this is how I can add the one more parameter called next router and create the routing table. Yes. So once I get the advertisement, I can I am finding another other advertisement stating that I have the better route to reach some other node. Then what can be done is I can update here. I can update in the routing table. See, from A, D is getting the information that A can reach Z with the number of hops 4, whereas here D can reach Z with the number of hops 7. So which is best one? The advertisement given by A is best. So D, what D does is, so it finds that it is going to modify its table, like through A, let it go, or let it send the packet and reach the Z. So from D to A, what is the cost? From D to A the cost is 1. Already it advertised that A can reach Z with the routing cost, that is 4. So 4 plus 1 is 5. So from D to Z through A will be 5, which is lesser cost. So with the help of the advertisement which is received from the different routers, the values can be modified if it finds the better path than the previous entry. Yes, whatever I said, that is mentioned. So if no advertisement heard after 180 seconds, what will happen? As I already said, if any router is not sending the advertisement for the duration of 180 seconds, then that router will be declared as dead, and it will be removed from the routing table. Its own entry will be removed from the routing table. Yes. Next. RIP table processing. How it is done is, RIP routing table managed by the application process called routed. It can also be called as daemon. The process is called as daemon. Advertisement is sent in the UDP packet periodically. So in the UDP form, using UDP packet, the advertisements are sent. The RIP advertisements are sent. So this is how the RIP works. It is nothing but intra-autonomous system routing protocol, which uses distance vector routing to find the shortest path between the nodes in the same autonomous system. So advertisement messages are used every 30 seconds. It should be circulated between the nodes with which the routing table entry can be done. So with this, RIP gets over. I hope you have understood better. Thank you. Bye.